Hello everyone. We will now go through the solutions of question number 10 on project 1. The question says, given the point on the circle, determine the exact values of the 6 trigonometric functions of the angle theta. We have been given a diagram here of a circle within an xy coordinate plane. They've given us a central angle. It's called theta, and they've also given us a point on the circumference of the circle made by the terminal side of the angle theta. The coordinates of that point is -1, 3. Now, based on this information, we have to find all 6 trigonometric functions using the data given. Now let's look at the coordinates of the point given. It's -1, 3. What does that mean? That means the x coordinate of the point is -1 and the y coordinate of the point is 3. Therefore, if we look at our xy axis here, -1 is located on the negative x-axis. Let's mark this point as -1. That means the horizontal displacement of the point from the origin, from the point of intersection, is -1, correct? So this distance here is -1. The vertical displacement of the point from the origin is +3 units. Therefore, the point is located 3 units along the positive y-axis. That means this distance here along the y-axis to the point is 3 units. If we scale the y-axis as 1, 2, and 3, the point is located 3 units up, and horizontally it is 1 unit to the left of the point of origin. Now, given this information, we see based on the figure I just drew to show you what the x and the y coordinates mean, we see we've come up with a right triangle here. And here we have x. What is x? X is -1. We've already indicated that, but y is 3. So the base of the triangle has a measure of -1 and the vertical distance is 3. And then we have the hypotenuse, which is represented by the terminal side of the angle. So the terminal side of the angle has now become the hypotenuse of this right angle triangle, right? So we know the value of x, which is -1. We know the value of y, which is 3. Our next task will be to find the value of the hypotenuse, and that hypotenuse I'm going to denote by the letter r. That is also the radius of the circle given. So here I have x equals -1. Always write out your data first. X equals -1, y equals 3, we have to find r. R can be found using the Pythagorean formula, which is x squared plus y squared equals the hypotenuse squared, or the r squared. So take your value of x, which is -1 whole squared. A value of y is 3, therefore 3 squared equals r squared. -1 squared is 1. 3 squared is 9. Add them together and you will get the value of r squared. Therefore, r squared would be equal to 10. Let me just add that step here. So 1 plus 9 is 10 equals r squared, but we have to find r. So we end up taking the square root of both sides to get r equals square root over 10. And that's how we came up with square root over 10 for the value of r. Let's write that. R equals square root over 10. Now that we have all the values of this right triangle, x equals -1, y equals 3, and r equals square root over 10, we can find all 6 trigonometric ratios. Sine equals opposite over hypotenuse. The opposite side to the angle is y and the hypotenuse is r. So y divided by r. Make sure you're plugging in the values correctly. Y has a value of 3. R has a value of square root over 10. We have to rationalize the denominator because we do not like to leave the denominator with a radical sign. Therefore, multiply both the denominator and the numerator by square root over 10 and you'll end up with 3 times square root over 10 divided by 10. Recall, square root over 10 multiplied by another square root over 10 is 10 without the radical sign. Cosine of theta is x divided by r, x being the adjacent side over the hypotenuse. The adjacent side has a value of -1, r has a value of square root over 10. Again, you will need to rationalize the denominator. Same way that we did for the sine, you will end up with negative square root over 10 by 10. Now, keep in mind that the angle theta is a second quadrant angle. Cosine is negative in the second quadrant. Therefore, make sure your cosine ratio has a negative value. For the tan of theta, tan equals opposite over adjacent. So, opposite side is y, adjacent side is x. So, y divided by x, y equals 3, x equals -1. So 3 divided by -1 gives us -3. Again, for a second quadrant angle, tan will be a negative value, and that's what we have here. Cosecant of theta. Cosecant is the reciprocal of the sine function. If sine is y divided by r, then cosecant will be r divided by y. It's square root over 10 for r divided by 3 for y. So square root over 10 divided by 3 gives us square root over 10 divided by 3. There's no way we can simplify this any further, or neither do we need to rationalize this. Secant of theta. Now, secant is the reciprocal of cosine. Therefore, if cosine is x divided by r, then secant would be r divided by x. Plug in the values again correctly. After plugging in the values for r and x, we end up with square root over 10 divided by -1, which is negative square root over 10. Again, secant and cosine both should be negative in the second quadrant, and that's what we got here. For cotangent of theta, now cotangent is the reciprocal of the tangent function. Therefore, it'll be x divided by y. Plug in the values for x, -1. Plug in the value of y, it's 3, which is equal to -1/3. Again, make sure tangent and cotangent ratios for the second quadrant angle are negative values. So this is how you can find all 6 trigonometric ratios when you're given a point on a circle with its coordinates. All right? Now let's work on question number 11, which says, state the quadrant in which angle theta lies. There are 2 parts to this question. The first part gives us information on 2 of the ratios related to angle theta. Sine of theta is greater than 0 is one piece of information, and the other says cos of theta is less than 0. So we haven't been told what the angle measure is, neither have we been told what the ratios of the sine and the cosine functions are for that angle. All that we've been told is that the sine of the angle is positive. Greater than 0 means the sine of the angle is positive and the cosine ratio for that angle is negative. Based on that information, we have to figure out in which quadrant the angle could be. We will use our ASTC rule. We have the 4 quadrants, 1, 2, 3, and 4. In the first quadrant, all trigonometric ratios are positive. In the second quadrant, sine and its reciprocal, the cosecant are positive, all other ratios are negative. In the third quadrant, tangent and its reciprocal, the cotangent are positive, everything else is negative. And in the fourth quadrant, cosine and its reciprocal, the secant, are positive, all other ratios are negative. Given this diagram here and the information provided on the sign of the ratios, let's try to figure out in which quadrant the angle could be. It says sine of theta is greater than 0. A sine of theta can be positive only in quadrant 1 and in quadrant 2. Only in these 2 quadrants would sine be a positive ratio. However, we have to narrow down our choice to 1 quadrant only. The same angle cannot be in 2 different quadrants, correct? Therefore, we will use the second piece of information given, which is cos of theta is less than 0. Now, if cos is a negative ratio, it cannot be a first quadrant angle because all ratios are positive in quadrant 1. In the second quadrant, cosine is negative. So that is the quadrant in which the angle would lie. Because both conditions are satisfied in quadrant 2. Sine is positive and cosine is negative. Therefore, we eliminate quadrant 1 and we have quadrant 2 as our choice. Therefore, the answer is quadrant 2 is where the angle lies. Part B says tan of theta is less than 0 and secant of theta is greater than 0. Therefore, tan is a negative value for that angle and secant is a positive value for that angle, whatever the angle measure is. That's the second case given to us. Again, we will use the diagram of the quadrants here. Now, tangent is less than 0. Tangent is negative, means it cannot be a first quadrant angle. It cannot be a third quadrant angle either because tangent and cotangent are positive there. It can either be a second quadrant angle or a fourth quadrant angle. Now we'll have to eliminate one of these two choices. So for that, let's look at the sign that goes with secant. Secant is a positive value. Now, secant is the reciprocal of the cosine function, correct? Secant is negative in quadrant 2. Therefore, we cannot have the angle in quadrant 2. Let's cross that out. Quadrant 4 is the correct quadrant in which the angle would be located if tangent is negative and the secant ratio is positive for that angle. All right. We will now work on question number 12, which is to find the exact values of the remaining 5 trigonometric functions given that secant of theta equals -2 and tan of theta is greater than 0. Given this information, we have to find the ratios of all other trigonometric functions. In order to do that, we will need to find the values of x, y, and r. And once we do that, we will be able to put together all the trigonometric ratios. But before we go on to that, we first have to determine in which quadrant angle theta could be. So we will use this information given to us that secant theta is -2 and tan of theta is a positive value. Given that information, I'm going to use the ASTC diagram to determine in which quadrant the angle would lie. In the first quadrant, all the ratios are positive. In the second quadrant, only sine and its reciprocal, the cosecant, are positive. In the third quadrant, it's the tangent and its reciprocal, the cotangent, that are positive. And in quadrant 4, it's the cosine and its reciprocal, the secant, which are positive. Now, secant is given to us as a negative ratio. Therefore, it cannot be in quadrant 1. Let's cross that out. It cannot be in quadrant 4 either because secant is positive there, it being the reciprocal of the cosine function. So let's cross that out too. The choice is between quadrant 2 and quadrant 3. We have to narrow it down to one quadrant only. In order to do that, we will use the information that tan is positive for the angle. In the second quadrant, tangent is negative. Tangent is positive only in quadrant 3 and quadrant 1. We've already eliminated quadrant 1, so we will now eliminate quadrant 2. Therefore, the angle theta lies in quadrant 3, and that's where both the conditions are satisfied. Secant is negative there, and tangent is positive in the third quadrant. So our choice is quadrant 3, where the angle lies. Now we will find the values of x, y, and r. Now, secant ratio is given by the formula r divided by x. Cosine has the formula x divided by r. Since secant is the reciprocal of that, just flip the numerator and denominator of the cosine and you get the formula r divided by x. But the ratio given to us is in the form of an integer. We have to rewrite that in the form of a fraction, showing a value for r and showing a value for x. We have a negative sign. To which one do we assign the negative sign? Should we assign it to r or should we assign it to x? R is going to be positive no matter in which quadrant the angle lies. Only the x or the y will take the negative or the positive sign, correct? So I will write 2 as a positive value, and that is going to replace r, and x will have the negative sign. It has a value of -1, and that will give us -2, correct? However, here we've broken the -2 and shown it as r being a +2 and x being a -1. Now that we know the value of x, -1, and r is a +2, we will use the Pythagorean formula to find the value of y. The formula is x squared plus y squared equals r squared. Plug in the value for x, which is -1 whole squared, plus y squared equals 2 is the value of r, therefore we have 2 squared on the other side of the equal sign. -1 whole squared is +1 plus y squared equals 4, and then we have y squared. We solve for y, therefore first move the 1 over to the other side by subtracting 1 from both sides. We end up with y squared equals 4 minus 1 is 3. Take the square root of both sides and we end up with y equals square root over 3. However, this being a third quadrant angle, you always have to keep in your mind the quadrant in which the angle lies. Y will be a negative square root over 3. All right, so when you write the final value for y, remember to make it negative square root over 3. Both x and y would be negative values. Now that we found all three values, x, y, and r, we are going to work on putting together the different ratios. Sine of theta is given by the formula y divided by r. Y is negative square root over 3 and r is 2. Therefore, our answer is negative square root over 3 by 2. Cos of theta is x divided by r. X is -1, r is 2. Answer is -1/2. Tangent of theta is y divided by x. Y has a value of negative square root over 3. X has a value of -1. Therefore, negative and negative divide to become positive. So square root over 3 is the answer for tan. Cosecant of theta is r divided by y. It's the reciprocal of the sine function. So r divided by y would be 2. R is positive. 2 divided by negative square root over 3. We have to rationalize the denominator to remove the radical sign. Multiply both the denominator and the numerator by square root over 3, and we get an answer of -2 times square root over 3 by 3. And finally, for cotangent, cot of theta is x divided by y, which is, again, plug in the values. X is -1, y is negative square root over 3. Negative and negative will become positive. We have to multiply both the numerator and the denominators by square root over 3 to rationalize the denominator, and we end up with a value of square root over 3 by 3. So for the third quadrant angle, we have to make sure both tan and cotangent are positive ratios. All the other ratios should be negative. So you can just cross-verify that. All right? We will now work on question number 13, which is about finding the reference angle for each of the given angles. Now, it's always helpful to draw the angle because we first have to determine in which quadrant the angle lies. Because to find the reference angle, there is a different formula for angles in different quadrants. So first we have to know in which quadrant the angle lies and then apply the appropriate formula for that quadrant to find the reference angle. The first angle given to us is in degrees, and that's 322 degrees. So I'm going to first draw this angle and determine where it lies on the xy coordinate plane. Here we have our y-axis and the x-axis intersecting. I'm going to mark the quadrantal angles first. Since we are working in degrees, Let's mark them in degrees. We have the 0-degree angle at positive x-axis. Then on the positive y-axis, it's a 90-degree angle. Then we have 180 degrees diametrically opposite to the 0-degree angle. Down below, we have 270 degrees. And then when we come around a full circle back to the positive x-axis, we make a 360-degree angle. Now, 322 degrees is an angle measure between 270 degrees and 360 degrees. Therefore, it's a fourth quadrant angle. I'm going to draw the angle anyway. So here I start from the positive x-axis and turn in the anti-clockwise direction for a positive angle. And let's stop somewhere here. And here is our angle, 322 degrees. We have to find the reference angle for it. And the reference angle will actually be this angle between the positive x-axis and the other side of the terminal angle. Therefore, this is the reference angle for the 322-degree angle. Since this is a fourth quadrant angle, the specific formula to find the reference angle would be 360 degrees minus theta. I'm going to write on the side the different reference angle formulas for the different quadrants. We start with quadrant 2. In quadrant 2, the formula in degrees would be 180 degrees minus theta. Theta being whatever angle we have to find the reference angle for. For quadrant 3, the formula is theta minus 180 degrees. For the fourth quadrant angle, it's 360 degrees minus theta. Now, if we are working with radians, then you have to replace the 180 degrees with pi and the 360 degrees by 2 pi. All right. So this being a fourth quadrant angle, the formula we'll need is 360 minus theta. Let's go through the steps here. 322 degrees, we first determined it's a quadrant 4 angle in the diagram. And then the reference angle formula is 360 minus theta. So 360 minus 322 degrees, which gives us a value of 58 degrees. Therefore, 58 degrees is this green angle here between the positive x-axis and the terminal side. So this angle measure is 58 degrees, and that is the value of the reference angle of the 322 degrees. All right. Now, the next angle is in radians, and it's a negative angle. Now, if the angle is negative and we need to find the reference angle for it, we first must find its coterminal angle, and then we'll find the reference angle of the coterminal angle. So first, I'm going to begin by drawing the angle and determining in which quadrant the angle would lie. So again, here's my XY coordinate plane. Because it's a negative angle, our angle will be formed by moving in the clockwise direction from the positive x-axis. But let me mark the quadrantal angles this time in radians. So we start with 0 radians, and then pi over 2 on top, and then pi opposite to 0. And then we have 3 pi over 2, and then one complete round gives us 2 pi radian angle, right? So to sketch negative 2 pi over 3, we have to move in the clockwise direction. So clockwise from the positive x-axis, let's go here, and 2 pi over 3 is pi over 3 less than pi, correct? So 3 pi over 3 would make it pi units. So 2 pi over 3 will be pi over 3 units less than 3 pi over 3. So we are going to stop somewhere in the third quadrant, which is, let's mark it here. Again, this is a rough sketch. It's very approximate. So here is our angle of negative 2 pi over 3. It's a third quadrant angle. Now that we know in which quadrant it lies, this being a negative angle, we have to first find its coterminal angle. What is the coterminal angle? It's a positive angle which is less than 2 pi that starts from positive x-axis in the anti-clockwise direction and comes and stops at the terminal side of the angle, which is negative 2 pi over 3. So it's this angle here, starting from the positive x-axis, moving in the anti-clockwise or counterclockwise direction and stopping at the terminal side. This is the angle we need to find. To find the coterminal angle of this negative angle, we add 2 pi to it. So just to find this coterminal angle, we will add 2 pi to the negative 2 pi over 3. So first find the coterminal angle. For that step, I've added 2 pi. So it's negative 2 pi over 3 plus 2 pi, which gives us 4 pi over 3. Again, this is a fraction addition or subtraction, if you want to call that. The way we worked it out is negative 2 pi over 3 plus 2 pi. We have to give the 2 pi a common denominator of 3. So we'll end up with 6 pi over 3. Now that we have a common denominator, we can subtract or add the numerators, whatever you please. And that would give us 4 pi over 3. And that's what we got here. Now that we have the coterminal angle, we can go ahead and find its reference angle. It's a third quadrant angle, so we have to pick the formula for the third quadrant. It's going to be theta minus pi. 180 degrees, you have to replace that with pi because we are working in radians now. So 4 pi is our theta, minus pi gives us pi over 3. It's this angle between the negative x-axis and the terminal side. This is what the reference angle is, and that angle measure is pi over 3. That's the reference angle. So we've completed the steps one by one to find the reference angle, one of them in degrees, the other one a negative angle in pi. Remember the steps, how to work it out when it is a negative angle. All right? Question number 14 is the last question on the project, and this will give us some more practice on finding reference angles. And these questions ask us to go one step further to find the sine and the tangent function for the given angles. It says, find the exact value of each expression with the aid of its reference angle. Again, it's always helpful to draw the angle. Now, I have gone through the process of finding reference angles in some of the past questions, so I'm not going to spend too much time this time. I will just explain the steps I have here. The first question is to find the sine of negative 210 degrees. First, we have to determine in which quadrant negative 210 degrees would lie. So in our xy coordinate plane, because it's a negative angle, we have to move in the clockwise direction from the positive x-axis, and this is 180 degrees, correct? So 210 is over 180 degrees. That will take us into the second quadrant. So 210 degrees will be an angle in the second quadrant. That has been established now. That's how we decided it's in quadrant 2. And because this time we also have to find the ratio for it, we are being asked to find the sine ratio. Let's make a note that in the second quadrant, sine will be positive. Therefore, our ratio that we eventually come up with will take a positive sign. The next step is to find the coterminal angle for this negative 210 degree angle, correct? What is the coterminal angle? It's going to be the positive angle from the positive x-axis all the way to the terminal side of this angle. It should come and stop at the same terminal side for negative 210 degrees. To find this measure, this green angle, the formula is just add 360 degrees to negative 210 degrees. That will give us the coterminal angle. So to find the coterminal angle, we add 360 degrees to negative 210 degrees, and we come up with an angle which is 150 degrees. So this green angle is 150 degrees using the formula to add 360 degrees to the angle in question. All right, so that's how we get 150 degrees. Now we have to find the reference angle of 150 degrees. Because it's a second quadrant angle, the formula is 180 minus theta, correct? That's the formula. So to find the reference angle of 150 degrees, it's 180 degrees minus theta. Here is the coterminal angle, 150 degrees. When we do the subtraction, we get 30 degrees. That's our reference angle. So here in this picture, which is the reference angle? It is this angle here between the negative x-axis and the terminal side. just this angle. That's what the 30-degree reference angle is. Now we have to find its sine ratio. For the second quadrant angle, for sine of negative 210 degrees, which is equal to sine of 150 degrees, which will be equal to the positive sine of the reference angle, which is 30 degrees, is positive 1/2, and that is the final answer. All right. Now the next question has the angle given to us in radians, and we have to find the tangent of 13 pi over 3. Now 13 pi over 3 is a first quadrant angle. How does it become a first quadrant angle? Usually we know that the first quadrant angles are angles between 0 and pi over 2 radians, correct? But how does 13 pi over 3 become a quadrant 1 angle? That means it goes over 2 pi. It goes over at least one cycle. Let's see how many circles we should make. 13 pi over 3. So the closest angle to 13 pi over 3, which will be multiples of 2 pi, would be 12 pi over 3, correct? 12 pi over 3 is 4 pi. It's a positive angle, so we turn in the counterclockwise direction. In other words, go one circle, that brings us to 2 pi, and then go another circle, that brings us to 4 pi, and then we have to go another pi over 3 units over the 4 pi and stop somewhere here. And this is our angle, which is 13 pi over 3. All right, and that's how it is a first quadrant angle. After making 2 rounds of 2 pi and then coming and stopping in the first quadrant. To find its coterminal angle will be to subtract multiples of 2 pi. When our angle is a positive angle, then you subtract multiples of 2 pi. When your angle measure is a negative angle, then you add multiples of 2 pi. That's the formula to find coterminal angles. So coterminal angle between 0 and 2 pi would be 13 pi over 3 minus 4 pi. 2 times 2 pi, multiples of 2 pi. And when we do that subtraction, we get pi over 3, which is this angle here. This is the coterminal angle, pi over 3, correct? That's a coterminal angle. And for first quadrant angle, the reference angles don't apply. Reference angles only apply for quadrant 2, quadrant 3, and quadrant 4 angles. Therefore, we don't have to worry about reference angles for this. Pi over 3 itself is the reference angle for that particular coterminal angle. So tan of 13 pi over 3 is going to be the same as tan of pi over 3. For a first quadrant angle, all ratios are positive. We don't have to worry about determining the sine of the angle. It's going to be positive. So tan of pi over 3 has a ratio which is square root over 3. That's the final answer for this question. All right.